Okay, guys, welcome back to Grade 9 Science in the Optics Unit. Today we're going to be reviewing the Gizmo that you guys just completed for last class on ray diagrams of lenses. And then we're going to dive into converging lenses and get a little bit more practice on drawing ray diagrams specifically just for converging lenses. We're going to kind of narrow it down. And then I have a few attachments for you guys to view. So let's get started with a review of the Gizmo. So I'm going to share my screen to you guys now. So the Gizmo starts out with two kind of prior knowledge questions. The first question was just asking you to draw the rays. So with a converging magnifying lens, we should see the rays that are parallel converge onto one specific spot, that spot being the focal point of the lens. So why is a convex lens useful for starting fires? Well, we know the convex is converging, so those rays are going to converge to one spot. Therefore, it's going to concentrate the energy from the sunlight, and that's why it can be useful for starting a fire. The Gizmo warm-up questions ask you to get used to the Gizmo and be able to make use of the moving virtual and real focal point, as well as moving the candle around the screen. So they ask you to colorize the lines and focus in only on the parallel line so that the central and line through focal point were turned off. What is always true about the light ray that emerges from the right side of the lens? The line that emerges from the right side of the lens always passes through the focal point when it was incident parallel to the principal axis. That was question number one. Question number two asked you to turn on only the line through the focal point and ask what you notice about that line on the right side of the lens. And if an incident ray goes through the focal point and then makes contact with a converging lens, it will refract parallel to the principal axis or horizontal. Okay, in the activity now, question one asks you to observe in its current configuration the distance from the candle to the focal point when it's set to a focal point of 12 and a distance from the focal point to the candle of 12 at 24 total units. What do you notice about the orientation of the candle's image on the right side of the lens? We should have noticed that the image was upside down when given the parameters listed here at the beginning of the activity. What did you notice about the size of the image? The image should have been the same size as the candle because we were at 2F. Any questions so far on what we've covered?
No.
Just using the raise a hand feature on Zoom. Owen's got a question.
Yeah, I have a question. I was doing the Ed puzzle.
Yep.
And I guess the thing it said if it was beyond the 2F point, it said it would be smaller, and I guess smaller, and it said it was wrong.
Okay, so we're going to talk about the Ed puzzle in a moment because you're not the only one that had that issue. That was forwarded to me by another student as well. I think there was just a mislabeling in the Ed puzzle, so I'm going to try and correct that and take a look at everybody's grade, and I'll probably have to award everyone a free mark on that one. Okay, just a mistake in Ed puzzle, so I apologize for that, but we will talk about the Ed puzzle momentarily. Okay.
All right.
Any questions about the Gizmo so far, guys?
I think we're good.
I think we're good. Awesome. Okay, question two asks you to investigate what would happen when you moved the candle around or moved the focal point. So with the candle in its original position at 24 and the focal point at 12, it asks you to move the candle to the left and observe what happened to the image. The effect on the image you should have seen was that the image moves to the left and gets smaller. So as we move the candle further away from the magnifying glass with a focal point of 12, the image gets smaller and it moves to the left. Then when asked what happens when you move to the right, the image moves to the right and it gets bigger. So as you get closer to the focal point and closer to the magnifying lens, the image will get bigger. Moving the focal point now to the left and keeping the candle in its position at 24, the image moves to the right and gets bigger. Okay, so moving the focal point closer to the image made the image get bigger and move to the right. Move the left focal point to the right, the image moves to the left and gets smaller. So what do you guys learn from this?
That if for the first one, if you moved it to the left, it would move the same way and get smaller. But then the second one, if you moved it right, it would also move right and get bigger. And then the other two is the opposite.
Yeah, so generally speaking, the closer an image is to the focal point or the lens itself, the bigger it's going to look. Okay, so that's why we need to have an image located in its focal point. And that's kind of how telescopes and magnifying lenses work in the lab as well. And we'll talk about that more specifically as we go through the course and develop our understanding of converging lenses. But just know that is the science that's being applied to a telescope. That is the science being applied to a magnifying glass. So when we're doing those experiments in the lab in grade 10 and we get to use our telescopes, those are some things that we'll be looking for sure. Okay, question 3 asks you to analyze the image size related to the distance between the candle and the focal point. We already kind of went over that general rule. As the distance between the candle and focal point increases, the image gets smaller. The image grows larger as the distance between the candle and focal point decreases. Okay, we already kind of talked about that generalization. Now it asks us to flip the position of the candle and the focal point. So now we've got the candle at 12 and the focal point behind the candle at 24. Shortening the candle so we can see the whole image, what do you notice? Well, the image is magnified and located to the left of the candle. So the image we see is obviously a virtual image because there's no actual light rays converging there. We're seeing the extension of the refracted rays. Question 5 looks at a concave lens once we've returned our candle back to the original position at 24 and the focal point of 12. We then selected concave lens and noticed that the refraction, well, they refracted a different way. They didn't converge to a focal point. They seemed to diverge away from a specific focal point. So what did you notice? The 3 lines spread apart. More importantly, the scientific terminology that we want to use and apply here is that they were diverging. So turning on apparent lines, we were able to see that this is a virtual image because no light is focused at that location. It is an extension of the virtual rays. So move the candle back and forth no matter where the candle is placed. What is true? The image is always upright, it's always virtual, and it's always smaller than the candle. D, what would an observer see if she looked at the candle through the concave lens? The observer would see an upright virtual image that is smaller than the candle. Okay, any questions so far?
Is it okay if we wrote it a bit differently?
Of course, yeah, in your own writing is totally acceptable. Okay, and then the summary, a sample answer, and again, this is going to be totally different than what you guys have written as long as you get the general themes here. That's what I'm concerned about. So the general theme is that convex lenses produce real and virtual images. Real images form when the rays converge to a focal point, and these images may be magnified or shrunk depending on the distance between the object and the focal point. Virtual image is produced when the object is located between the focal point and the lens, and that concave lenses only produce shrunken virtual images that are always upright and always smaller than the candle. Okay, so convex can magnify and shrink an image depending on its location. Concave always will shrink the image and make a virtual image. Any questions so far? Okay, if there are no questions, that is it for the review of the Gizmo. So let me just close this out now. Okay, now to today's date on the planner. What we're going to do today is we're going to have you guys watch a Converging lenses on Edpuzzle and then work through worksheet 7 in your OneNote. So you guys should have already downloaded all of these things. They should already be in your OneNote, located under the lenses file. So when you downloaded lenses, I'm just going to move you guys around my screen here so that I can access things. Converging lenses ray diagrams. So the Edpuzzle will explain all of this in depth, but what you guys need to know is you need to know the general rules and locations. Now, as mentioned previously, there is an error in the Edpuzzle. So let's flip over to Edpuzzle and talk about specifically what that error was and what we're going to do moving forward. So the error was that if there was an image, I believe, the question asked about if there's an image beyond 2F. Is that correct? Can anyone confirm for me? The image beyond 2F?
I think that's what Owen said.
So if we direct our attention to this first image here in the OneNote, it says that if an image is beyond 2F, an object is beyond 2F,
That's inside
will the
2F.
image produced. So if an object is beyond 2f, will the image produced it be increased or decreased in size? It should have shrunk in size, and I'm being told that the Edpuzzle has the wrong answer for that question. So I will go through and mitigate that for you guys on my own end. But for now, I don't want you guys to sweat that. Go through the Edpuzzle, answer the questions correctly, and if there is a mislabeling, fire me an email, and I will take care
It's
of it.
not that. No, it's like, can you hear me?
Yeah.
Owen? Owen, you're good. I can hear you. Owen.
His audio's broken. He can't hear anything, but he can talk.
Hello? I don't know if you can hear me, but my audio broke and I can't hear anything, so I have to reset my laptop.
Okay.
I can't even hear anything.
Can somebody else tell us which question number it was that needs to be edited?
Second last.
Yeah.
Focus light in one area.
The second last. Okay, so the second last question on the Edpuzzle says, when the object
Oh,
is
wait, no.
beyond
Not
f,
second.
The third last. It's the third last.
Yeah,
Yeah, the one before that. I got it wrong too.
when the object is beyond 2f, what size will the image be? The answer should be smaller,
Yeah, that's what I said. It said bigger.
and it's saying bigger. Okay, so that's 1 out of 6, so I will definitely make sure that everybody gets that mark for free. So everyone gets at least 1 out of 6 on the Edpuzzle. Yay, free marks. I'm very sorry for the inconvenience, guys.
Yay.
Still some learning curves as we transition to online learning here, but I will make that edit so that for next year, the grade 9s won't have to go through the same thing, okay? All right, so your homework then. Worksheet 7 will give you guys some good practice for convex images. What I want you guys to do is working away at your own pace. I would like it if you could draw all of the ray diagrams for these images here.
Do they have to be like precise?
Labeling F and 2F is important for this one, yes. But do you need to use a ruler? No. If you want to print it out at home, if you have access to a printer, it might make it a lot easier for you. But I do want to make sure that everybody's at least labeled F and 2F and has the 3 lines for the rules that we learned in the Edpuzzle and that are available to us in the note. I want to make sure that we've got the 3 lines that we know the rules for converging lenses, the 3 rays following the 3 rules, and F and 2F are labeled and salt is filled out. That's what I'm looking for.
So should we watch the Edpuzzle before doing it?
I highly recommend that you watch the Edpuzzle before doing that. And I will flip back over to the note now. So that if anybody has any questions about the 3 rules that we've gone over, we went over these rules in the Gizmo as well as in the PhET simulation. But if we have any questions about the specifics of the rules for drawing ray diagrams for converging lenses, please raise your hand using the Zoom raise hand function now, and I will certainly address any of those.
Mr. Gay?
Yeah.
This homework is due next class, right?
Correct.
One.
Okay, we've got a hand up. Jack.
On the OneNote, there's some where the image is off the page.
Okay.
Like for one of the diagrams, it just goes all the way to like the salt thing.
Oh, in worksheet 7?
Yeah.
Okay. That's okay, buddy. If you need to
I
draw
drew-
fast, you can,
I
or
still drew the arrow like there, but is that fine?
that's fine. Yep, good question.
And one more question.
Yep.
For the location, is behind the mirror the opposite side of the normal image?
I would
Not
use
the-
left and right. I would use left of the lens and right of the lens. Remember, we're talking about lenses here, not
Okay.
okay?
Yep.
Okay, guys, if there are no more questions, I'm going to stop sharing my screen. I will make
What?
myself available for any individual questions that you guys have. as you work your way through the ed puzzle and through the worksheet, okay? So, Kai has a question and Diego has a question before we part. Kai, you want to start, or Diego, whoever wants to go first? Looks like Diego's unmuted already. Diego, you ready to ask?
The worksheet 7, do we submit it like the last, like the Gizmo worksheet?
Do you submit worksheet 7? Yes, just like what you did with the Gizmo and the FET simulation. You're going to submit worksheet 7 as a PDF if possible. So file, export as PDF.
Perfect.
Mr. Gay, I posted a TikTok. It's pure fire on the chat.
Pure fire, awesome. I was hoping to see more. We didn't get to have a championship TikTok because only like 2 got posted and they didn't get any likes. So I thought that would be.
But this one finna get likes. It's pretty good.
Okay, all right. Let's set the number at 10 likes. If a TikTok link gets 10 likes, we'll air it on. If it's appropriate, we'll air it on our stream. So 10 likes for a TikTok link, and then we will air it on our live stream. Okay, Kai has a question. Kai Kang.
I don't have a question.
Oh, you're good. Okay. Jack Hargrave.
For the ones that are on the focal point, they have no image. So what do you want to put? What do we put in the salt? Nothing.
Yeah, no image forms. Tell me why.
Because
the lines are parallel.
Okay. Gon, looks like you have a question too.
No, nothing.
No?
No.
All right, good questions so far, Jack H. Any other questions, guys?
Come on, movie about it.
Boys.
Okay, you guys are free to work away on the ed puzzle in your worksheet now. Then.
Yeah, man.
All right, guys, I'm available.
Thank you, Mr. Gay.
Oh, big dub for Gonzalo.
Gone with a big congrats, Gone. I'm glad you were paying attention to the lesson today. Okay, guys, I'm going to stop the recording now then and publish it to YouTube.